Okay, here is section 6.1.1. What happens when you draw an altitude to the hypotenuse of a right triangle? Well, it turns out that it creates similar triangles. In fact, it creates three similar triangles. And let's highlight why that's the case. Right away, you can see that let's see if I can get some blue in here. The right angles are here and here. And so one question I love to ask, how many triangles do you see? Hopefully you see three of them. The large triangle, the smaller one, and we can still talk about them as the large, the smaller, and the medium. Okay, and one of the ways to show similarity, of course, from chapter 5 is to establish the fact that two triangles are similar if two angles are congruent, two corresponding angles. Nice way to show this is to say in the large triangle, right? If I randomly say that angle G is going to be x degrees, right? So in the large triangle, that's x degrees. This is 90, and therefore this angle over here has to be 90 minus x. Now you have to take some time to think about that again. So for instance, if this is 20, this will be 70, right? Because it's the rest of the triangle, because all triangles add up to 180. So that's only if you needed to establish the fact that those are x and 90 minus x. I might even erase some of those because it's not really 20. And then if I look at medium triangle, let's make the medium triangle purple, right? The medium triangle here, if this is x degrees in this corner, this is the 90 minus x. Sorry, this is the 90, and then so this is 90 minus x at the very top in the purple triangle. In the, let's see, pink, the pink triangle, which is over here, we have 90 minus x. We have 90. And so this angle up here is x. And so what's really interesting, and it's a really important thing to watch, and maybe do this more than once if you need to. I'm going to redraw the three triangles. The large, right? And here's the right angle up here. Here is E. Here is Q. And here is G. It's awkward that they're a little bit the same, right? So this is the x angle, and this is the 90 minus x over here. Now, if I redraw the purple, I'm going to do this in purple, why not? That would be kind of smart. If I put that in purple, and I put the pink over here as well, right? So the pink triangle, which is the smallest, and this is why I like to sometimes call this the three bears, the large, the medium, and the small. I'm going to go through and take and match up. So the right angle for the large triangle is E. The right angle for the purple triangle is right here, it's A. The 90 minus x angle for the large is Q. The 90 minus x in the purple, though, is up at E. So we have E, and that's the 9. So here we have 90, we have 90 minus x. Excuse me, oops. 90 minus x, not sure why that does that. And finally, we have x over here. And in the purple triangle, that's G. In the pink, we have the right angle at the very top. That happens to also be at A. The 90 minus x angle in pink is what? Let's show that this is going the right way. This is the 90 minus x angle over here, and that is going to be the Q angle, right? And pink, over here, the X angle will be up at E. Now in your mind you're going to have to think about these as flipping around, right? So the large triangle is in the same position, right, as the entire triangle. These have to be flipped and moved for purple and for pink. So spend some time thinking about that. What's really important though is that we now have triangle, okay? Let's say Q, E, G, which is the large, is similar to triangle E, A, G is similar to triangle Q, A, E. Really important idea to get a grip on, because we're going to then, in the next section, talk about the sides that are proportional.